So let's say this is the list that we're given and we need to find out the median from this list. So let's create and call find median function, and here we will pass the list and the kth index. K is the index at which we are going to get the element from this list after the sorting. For this example, this is the mid index, so this is math.ceil list.length divide by 2, list.length divide by 2 plus 1. So this is the mid index, and now we will pass the lower bound, which is 0, and the upper bound, which is the list.length minus 1, index of the last element. So now this will return us the median. So to get the median, let's create this function find median. Find median, and now let's pass the arguments list and k and lower bound low and high, which is the upper bound. So what we do to find the median in median of medians algorithm, we find out the index of the approximate median, right? So we are going to create a function get approx median index, and here we will pass list, low and high. These are the arguments that we will be needing. So this will return us the approximate median index. So let's create this function get approximate med index, and here let's pass these parameters low, high. And now here what we have to do, we need to do the chunking, that is the partitioning, and then we need to find out the median of medians, which we will use as the pivot. So here we are again going to create a function, and we're going to call it, and we're going to call it partition and get, or you can say partition and get pivot. So here we will pass the list low and high. So this will return us our pivot value. So let's go and get pivot by creating this function partition and get. This is partition and get, and let's pass list, low and high. And here inside this partition and get, we are going to do the partitioning to get the chunks of 5 elements each from this list. So we are going to do the chunking, and when we get the chunk, we're going to find out the median or mean from that chunk, and we're going to put all the medians from all the chunks in a medians array to find out the median of medians. So first let's do the chunking, and to store the 5 elements, we're going to need an array. This we're gonna call temp, and let's initialize it with null. And to store the medians of all the chunks, we're gonna need another array. Let's call it median array or medians array. So this will be an empty array initially. And now let's take a for loop to fill up the chunk from the list. So let's take for, and let's start it from 0, and it will go till a certain length. And what will be that length? Let's take another variable length here. Let's say here length equals to, this will either be 5, or if the number of elements are fewer than 5, then we're gonna take that number. So this will be high minus low plus 1, right? And this we're gonna do inside while. So till we have elements to create chunks from, we need to run this while. So while high is greater than equal to low, that is if there are elements in the list or in the array, we're gonna do the chunking, right? So here now let's come back to this for loop here. So this will be less than len. We haven't added const here, and also this low value must be less than or equal to high, right? It must not exceed high. Here, let's remove this and increment the I after each iteration. Now here inside this for loop, let's fill up the temp. Let's initialize it here as an empty array. So each time we go inside the while, the temp will start, we will start with a temp which will be an empty array. So now let's come here inside this for and fill elements in this temp. So we will start from low, right? So temp I is list low, right? And now let's increment the low. So it will fill 5 elements in this temp. So after getting 5 elements in this temp inside this while, we are going to sort this temp, right? So here after this for loop, let's sort this temp dot sort. We are going to sort this in ascending order, right? So here let's take a comma b and return a minus b. So this will sort the temp in ascending order, and now after sorting, we can find out the mid element from this temp, and we can put this mid element in the medians array. So here this medians array will start from 0. So let's take index which starts from 0. So this is the index, and here at this index we will put the mean from this chunk or from the temp. So this will be temp, and now the mid index which will be math.ceil temp.length divided by 2. So this is how in this while we will get all the means from all the chunks in this medians array, and finally we just need to find out the median of all these medians, right? So here we will return partition and get, that is, we are recursively calling this function again. This is because if the length of this medians array is greater than a limit, then we again have to do the chunking, right? So that's why this recursive call is must here. And now here inside this function at the start, we are going to check if the length of this medians array, that is high minus low plus 1, if this is smaller or equal to 9, then we can find out the median from this list. So we will sort this list A, B, and A minus B. So we are sorting it in ascending order, and then we will return the middle element from this list, which will be the median of medians. But if the length is greater than 9, then we are going to do chunking again. So here math.ceil list.length divide by 2 divide by 2. So here we are getting the median of medians from this. Oh, here we must increment the index after we add the mean from one chunk. So here we got the median of medians, which will be our pivot in this get approximate median index function. So after getting the pivot, we need to find out the right index for this pivot, and that we can do by using quicksort. So let's do this while left is smaller than right, while low is smaller than high, And here, while value at low is smaller than the pivot value, then we need to go towards right. So here we will increment the low to go towards right. So low plus plus, and if, let's indent it, and now here, while the value present at high is greater than pivot, then we have to move towards left. So we will decrement the high here. High minus minus. And if the value present at low and high both are equal, list low equals to list high, then let's increment low. Low plus plus. And if both the pointers are stuck, we cannot move either ways, then we must swap the elements. So here we will check else if low is smaller than high, because before swapping we again have to check if the low pointer is still smaller than high or not, because there's no guarantee that after running these while loops still low is smaller than high. So let's take temp and let's get the value at low in temp, and now at low put the value present at high, so list high, and now at high put the value that we took in temp. And finally here we will return the high index. So here we got the index, which is the approximate median index. So it is possible that the median of the list is actually present at this index, but there's no guarantee for it. So here let's take it in const, and let's call it median index for now. And now let's calculate the length again. So here say const length, and this will be, we will take median index minus low plus 1. So this is the length till this index, and here we will check if this length equal to k or not. If it is equal to the k, then this median index is actually the index of the median. So in that case, here we will return the element present at this median index, which is the result. So median index, and if this length is greater than k, then we have to go to left to find out the median, because median is present at the left to this median index. So here we will pass the list, and k, low will be low and high will be median minus 1 as we're going to left. So median index minus 1. Else we have to go towards right. So here let's take else, and we're gonna go towards right, or we're gonna go in right direction, and here we will return find median. So this is the recursive call where we will pass the list, and the new k will be k minus length, and it will start from median plus 1 as we're going towards right, and the high will be the high for this call. So here let's pass high. This is it. Now here we will get our median, and now let's print this result. So console.log, and let's print this result. Let's say median is median. Median. So let's save this and let's run this. Go to terminal and First, let's go to divide and conquer and now node median of medians, median, and see the result. We got 24, which is the median of this list.